But our next topic of study that we're going to embark upon is electrochemistry, which is essentially the study of how you make batteries. So it's a pretty interesting topic, but there's a few prerequisite concepts that you need to know. Okay, so I'm going to teach you the first one today, or review with you how to determine oxidation numbers. Pretty straightforward. Oxidation number is it's a way of keeping track of electrons. And if you have an ion, it's equal to the charge of the monatomic ion. Okay, so if you have sodium plus, its oxidation number is +1. Okay, if I have S2 minus, its oxidation number is -2. Okay, so oxidation number equals charge if you have something that's charged. It's also equal to the charge an atom would possess if the shared electrons were assigned to the more electronegative atom. Okay, so I've got oxygen in water. Who's more electronegative, the oxygen or the hydrogen? The oxygen, right? And so what we do is we assign all of the electrons from the bonds to oxygen, giving it an oxidation number of -2, right? But it's artificial. It's just a way to keep track of the electrons. And I'm going to teach you the rules, so you don't have to what was that about oxygen? All right, so 3 simple rules. If it's an element with no other elements, its oxidation number is 0. Hydrogen gas, H2, each hydrogen is 0 because it's uncombined with other elements. Okay, magnesium metal. What's the formula for magnesium metal? Mg, right? And I heard a couple, 2+. But remember, if it's just magnesium metal, if I have a strip of magnesium that I can form and shape, that is not Mg2+. That is the neutral element. Okay? So if you just see Mg and no one's written a charge on it, then guess what? Its oxidation number is 0. Because it's just an element. Okay, now it would be +2 if it were in an ionic compound. Okay, so in this compound, Mg is 2+, and its oxidation number is +2. Okay, so the plain element not combined with another element is 0. Right, we already said this, oxidation number of any ions equal to its charge. Ca2+ has an oxidation number of +2. If I did K2S, this is an ionic compound. Metal, non-metal. As soon as you see an ionic compound, you have to think to yourself, ions, okay? Things with charge. So what is K's charge? +1. Now notice, I'm not talking about the total charge. I'm talking about the oxidation number of each individual K atom, all right? So each K is +1. What about sulfur? What's its oxidation number? -2 in this compound. All right, sulfur, by the way, can vary. All right, so the sum of the oxidation numbers is equal to its total overall charge. So you need to know these rules. You need to know, number 2, and that the oxidation number of hydrogen is always going to be +1 in combination with nonmetals and -1 in combination with metals. Okay, so these are a few little factoids that you need to memorize so you can figure out other oxidation numbers. Okay, oxidation number of oxygen is -2. In most of its compounds, we're not going to worry about the ones where it's not. If it's a halogen, give me an example of a halogen. Okay, thanks for playing. That's an alkali metal. Try again. Chlorine, fluorine, bromine. Okay, all those guys, those are -1 unless the halogen is in combination with oxygen or another halogen higher in the group. And we'll come back to that just so I can clarify that later. But let's move on. All right, so let's say I wanted to determine the oxidation numbers of sulfur. Okay. Oxygen, we know, because it's one of the things we need to memorize, is -2. How many of them are there? 2, okay? We don't know sulfur. Sulfur's unknown. That'll be our X. Does SO2 have a charge written on it? No. Okay? So overall charge is 0. So we want the oxidation numbers to add up to 0. So minus 4 for the 2 oxygens at minus 2 plus X is 0, and then X is plus 4. So notice sulfur has a different oxidation number in this compound than it did when it was sulfide. Okay, one more example. Sulfur is, we don't know, that's our X. How many oxygens? 4, SO4. What does each one of them have as an oxidation number? Minus 2, because that's one of the ones you just need to know. Now, SO4 has a charge. What is it? Minus 2. So the oxidation numbers, the sulfur oxidation numbers and the oxygen oxidation numbers, that's hard to say, have to add up to the charge. So X minus 8 is minus 2, and X would be equal to what? Plus 6. You add 8 to both sides. Okay, so for our last example, we're determining the oxidation number of chlorine in HClO3. And you might remember from above that we said the oxidation number of all the halogens is minus 1. And of course, fluorine, chlorine, bromine, and iodine are all members of the halogen group. So you might think that chlorine's minus 1. But notice that there's a caveat. It says unless the halogen is in combination with oxygen or another halogen that's higher in the group than it is. Okay, so in this case, the chlorine isn't in combination with fluorine, which would be higher in the group, but it is in combination with oxygen. And so how does that affect its oxidation number? Well, it changes it. And so let's look at all of these. So we're going to figure out what chlorine is. It's now unknown since it's in combination with our oxygen here. So hydrogen with nonmetals is plus 1. Okay, so plus 1. And so we'll say that's our known. Plus 1 is our known for hydrogen. We're going to add that to chlorine's unknown oxidation number, so plus X. And we're going to add that to oxygen's oxidation number. And there's 3 oxygens. Each one is minus 2, because that's one of the sort of known things that we are going to have memorized. And so HClO3 is an acid with a neutral charge. There's no charge on it, so that's 0. And so then we're just going to say plus 1 minus 6 is minus 5. So we get minus 5 plus X equals 0. And then if we add plus 5 to both sides, X is equal to positive 5. Okay, and so you can see in this case, chlorine is far from minus 1. Its oxidation number is actually plus 5. And the reason that we're wanting to determine these oxidation numbers is because we can look to see if the oxidation number is changing in a reaction for even one element. Okay, if you can see that it changes for even one element, you can tell that it's a redox reaction or an oxidation reduction reaction. So for example, if I had a reaction where we had sodium on one side and we were adding that to, I don't know, FeCl3 and making NaCl plus Fe, okay, this is not balanced, but the overall equation would look something like this. So I guess let's balance it. I could recognize this as being a redox reaction because I could look at the changing oxidation number. Sodium is 0 here because it's an element by itself. It's not ionically bonded, and there's no charge written on it. Over here, sodium is part of this compound sodium chloride. Its oxidation number is plus 1. And so therefore, sodium, since its oxidation number is going up, is being oxidized. And that means that there's something else in the compound that's being reduced. However, if we're just trying to tell if it's a redox reaction or an oxidation reduction reaction, we can just look to see. Once we see one of them is changing its oxidation number, we can automatically label it redox. Okay? And so in this case, the sodium is getting oxidized because its oxidation number is going up. And so that would make it the reducing agent. But we'll talk about that more in the next video on half reactions.